Hello class, welcome to today's lesson, which is the lesson 2 of the stage number 3, and the name is literal equations and formulas. Okay, I'm not gonna give you a very strong definition for what a literal equation is or what a formula is. Okay, I'm not gonna write down any formal definition. Basically, what I'm gonna show you is some literal equations and some formulas, and just by showing you the examples you're going to understand what this is about. So what is a literal equation, more or less? It's something like this. Okay, it's an equation. First of all, okay, we have in here we have three equations: a equals b times h, and what I'm trying to represent in this equation is the relationship between the area of a rectangle, okay, all of this area, okay, in terms of its base and its height. Okay, what is the relationship between these three quantities? Area of the rectangle, its base, and its height. Well, the relationship is that the area is equal to the base times the height, as we know since junior high, right? So this is a literal equation. Basically, it expresses the relationship between several quantities, but you never see any, or you you're not really seeing any like constant number like 3 or 5 or 1/2. Okay, they may contain these numbers, but it's most common to just observe variables like so, but there can be constants. For example, let me give you an example that I just thought up. What about this one? This is the area for a rectangle, right? The area of the rectangle is base times height over 2. So you see, you can encounter constants in literal equations, but you also encounter more variables, you see, more than one or more than 2 or 3 or whatever, any number of variables. Okay, so that is a very simple example. Now what about number 2? For example, what does this say? It says d equals bt, and we can interpret this formula as the formula for the distance traveled by an object. This is my object, is traveling in this direction. The distance in terms of the velocity of such object, how fast it's going, and the time that is going to be traveling, right? When these two quantities increase, the distance traveled by this particle will obviously increase. And what is the relationship between the distance, the velocity, and the time of this object? Well, this is the relationship, that the distance is equal to the velocity times the time. So this is also a literal equation or a formula. It's basically the same, okay? We can actually think of these two terms as synonyms. And I think a more complicated thing that you may have not seen so at this point. What about this? This looks complicated. P times V equals N times R times T. What are these things? Okay, if you put in physics, if you put in a cylinder a gas that we call an ideal gas, okay, it's sort of like a gas that behaves in a very good and easy manner. Okay, if we put in there an ideal gas in a cylinder and we cap the cylinder, okay, the gas cannot go away, it's trapped in here. Then we can measure all the following quantities. We can measure the pressure, okay, inside this cylinder, the pressure, the volume of the cylinder, okay, the volume of this whole cylinder, and is the number of molecules inside all of these little dots, okay, of gas inside the cylinder. R is a special constant, okay, this is like a it's a number, a very special number, and T is the temperature inside the cylinder, the temperature. So you can see that we have in here 5 quantities that relate to this phenomenon of trapping a gas on a cylinder, and those 5 quantities, pressure, volume, number of molecules or atoms, this special constant, which is called the Boltzmann constant, and the temperature, Okay, all of these things are related in this particular way. P times V equals nRT. Why? Well, because people have discovered this. Okay, there is an explanation for this. Well, if you study physics, okay, you can understand it. But we just use the formula basically. We accept it and we say, okay, this is a literal formula. I'm sorry, a literal equation or a formula. So that's what these concepts mean. Now, the exercises that are going to be performed today are going to be of the following type. I'm going to be giving you, or well, better, you're going to be reading exercises from the book that look a little like this. For example, I'm going to give you 3 examples. I'm going to give you a literal equation. Okay, it contains 3 variables, x, y, and z. And the book is going to tell you something like this. Pay attention because there are several ways to say the same thing. Okay, several ways to say the same thing. I can, for example, give you the first instruction. Well, let me write this symbol. Okay, I can tell you solve for x. Okay, this is the first instruction. So you're going to look at this literal equation, and what this instruction says is basically isolate the variable x. Isolate the variable x. So let's do it. I'm going to do it in here. I'm gonna start by multiplying -3 times this binomial. So I'm gonna get this, right? And then since I want to isolate x, what I want to do is keep all the terms with x, which is this one and this one. I want to keep them on the left side. You're going to see why in a moment. And this one, I'm going to bring it to the other side. How? By adding, right? By adding 3y. Not passing, but adding 3y. And then, why do I want to keep my terms with x in the left side? Because it's a good idea to factorize. Look, these 2 terms, this term and this term, share the common factor x. So I can factorize in this way. You see? And finally, since x is being multiplied by all of this number, consider all of this as a single package, a single number. Then if we divide both sides over such number, you see, I'm dividing both sides by such number, then I can use the law of cancellation. I can cancel this and this. And what do I have left in the left side? Only x equals z plus 1 plus 3y over 5 plus y. And we are completely done. At this moment, we say that we have solved this equation for x. ¿Ok? Hemos resuelto la ecuación para x, lo cual significa despejar la x, en pocas palabras. We solved the equation for x. Now, let me tell you other ways in which this same instruction is often told. All of these statements that I'm going to write mean exactly the same thing, okay? The author of a problem can tell you, solve for x, and then write in terms of, in terms of z, in terms of y and z. And it means exactly the same as this instruction. It means the same. Okay, what does that mean? It means that the x is going to be isolated in one side of the equation, and on the other side, you will have all of this, all the other variables that are told in this part. of the statement in terms of y and z. Resuelva para x en términos de y y z. That's what it means, okay? Having the x completely alone in one side of the equation and all these other variables in the other side. That's all it means. Let me tell you another way to say the exact same way. Some other authors write this, clear x, clear x. Okay, when you read this instruction, that also means to solve for x. It means to do the same thing we just did. Another way to say the same thing, isolate x. Okay, it means the same thing as all of these statements before. So all of these things, guys, 1, 2, 3, and 4, even though they look different and they use different words, they mean exactly the same instruction. And you have to do this that I just did. Okay, let's move on to another example. Example number 2. Okay, I'm gonna give you this literal equation. X times v equals s over t. And I'm gonna give you two instructions. One is solve for x, and the other instruction is isolate t. Okay, so we have two different exercises. First, we need to clear or to solve this equation for x, and then we have to do it but for t. Okay, because I mean, not only the x I can solve for, I can also solve for t or for v or for s. It doesn't make any difference, right? I'm gonna just follow the order that I'm being told. So let's start. I'm gonna first solve for x. I'm gonna write the same equation here, and I'm gonna solve this equation for x. It's very simple. If you notice, x has this v multiplying x. So how can I get rid of this v? Well, what you do is you divide both sides over v. You see, I'm writing this side as it was before. I'm writing this side exactly in the same way, and I just come and divide over v, both sides. Why? Because if I do that, this v and this v cancel one another, and all I'm left with is x on the left side, and in here we have s over t over v. I know this looks weird, guys, but it's perfectly fine. There's nothing wrong with this. We're just dividing a fraction over some variable. There's nothing wrong. Now, if you want to continue and simplify this thing, that's perfectly good. How can you do that? We can do the following. We can do this. S over t over v over 1. Okay? Because if I divide v over 1, I'm not really affecting the v, right? Why did I do this? So that this becomes a division of fractions. I'm dividing s. If you want to put like parentheses in order to differentiate between, in order to make the operation more explicit, you can do it. So I'm dividing s over t. I'm dividing it over v over 1. And you already know how to handle division of fractions. All we do is multiply this and this. We get s and t times v, and we get tv. So that's what we end up with, s over tv. So this is the final solution, but this is also the final solution. Okay, if you write this, there is nothing wrong with this. Both things are perfectly okay. This looks a little better, more simplified, but it's the same thing. Okay, now I want to isolate from the same equation. I want to isolate t. So let's see how that works out. We erase all of this. And now let's isolate t. So same equation. And now I'm gonna isolate t. Pay attention to how it's done. When the variable that you want to isolate is in the place of a denominator, like like here, what you want to do first is multiply both sides of the equation by such variable, by t. Look, I'm going to write the side as it was, and I'm going to multiply it by t. And if I do that operation on one side of the equation, I need to do it also on the other side, like so. Okay, so xvt, nothing happens. And when I multiply s over t times t, we know that both t's are going to be canceling one another, and you're going to be left with s. Okay, you can and going back to the word pass, I know that you can interpret what we just did. You can just look at this equation and say, okay, I'm just going to pass the t to the other side. It's dividing, so I'm going to pass it multiplying, and there it is, right? There it is. But remember, even though in some occasions that that pass methodology, okay, even though it works in some cases, number one, it doesn't work in all cases, and number two, that is an inappropriate way of thinking about algebra. And if you do that, you're going to create very, very bad habits. Okay, now I want to isolate t. I'm just going to divide all of this side over xv, because if I do that, and also the other side, obviously, if I do that, I know that I'm going to be canceling this with this, and I'm going to be left with this. And I'm done, right? I have isolated t, which is the instruction that I was given. So we have completed both exercises. So you see, in a literal equation like so, you can isolate any of the variables that you're given. It's not always the x, okay? The x has no, it's even though it's the most common variable to use, guys, uh, there is nothing really important about the x, okay? It's just a variable. There is nothing really important about the x. It's just for historical reasons that we use it so frequently that you think that it means variable, but you can use actually any other letter. Okay, number 3, f equals g times m1 times m2 over r squared. This is the general no, I'm sorry. This is the formula for the gravitational force between two masses. I don't know if you have seen it. It's a very popular formula in physics. And in here, I'm given two instructions. Let's write clear M1, that's the first instruction, and solve R in terms of F, G, M1, and M2. Okay, so let's start. Let's clear M1. So I have this equation, okay, and I want to isolate that variable. Okay, what do we do? First, when when your equation has denominators like in here, r squared, always try to make something, if possible, try to make something in order to get rid of denominators. So the first thing I'm going to do is multiply both sides by r squared, because by doing so, I'm going to be canceling this r squared, and that's a good thing. Okay, there it is. If you see, we started with this equation and we ended up with this other shape. It's the same equation, okay? Don't think they are different. They look different though, but it's the same equation. And an equation without denominators, like so, most of the times is more manageable than an equation with denominators. Okay, and finally, all we have to do, if you want to isolate M1, you can do this, like rearrange terms a little bit. G times M2 times M1, which is the same, right? And then we just divide both sides over GM2, and we're done. If you noticed, I did it autom automatically in here. I did not write the whole process. I just went like, okay, we have M1 here, and I have this little thing in here. Uh, so I can divide both sides, this side and this side, over GM2, and I'm gonna get this, and I'm done. FR squared over GM2. So as you can see, we have cleared M1. Okay. By the way, don't let these little things in the variables scare you. These are subindexes, and these things are used. Those are little numbers, okay, in here on the corner of the variables, very little numbers, just in order to differentiate one from the other. For example, if you have two people, if you're talking about two people, person one and person two, and you're talking about their masses, you may call the mass of the first person M1 and the mass of the second person M2, okay? And just with this little introduction of these little numbers in here, you know what mass you're talking about, okay? Whose mass? This is the mass of the first person, this is the mass of the second person. So these things come very in handy, okay? But this does not mean M times 1, okay? It doesn't mean M times 1 or M times 2. That would be a mistake. Okay, and finally, solve R in terms of G, M1, and M2. So now I'm asked to solve for R, or to isolate R. So let's do it. This. Okay, so I write down the same equation, and I start. I'm going to start the same way. I'm going to multiply both sides of my equation, this side and this side, by R squared. And when I do so, I'm going to get this. Same way I did it automatically, okay? I know that I can do this, that I can multiply both sides by R squared, and I just did it automatically. Now, R squared is being multiplied by F, so why don't we divide both sides by F? This is what you're gonna get. When you divide this side by F, you're gonna get this, and when you divide this side by F, you're gonna get this. You did not pass the F to the other side. You divided both sides over F. And finally, how can I cancel this square in here on top? Well, you can take the square root from both sides. Okay. So notice that I always do the same operation in both sides, always. And the square root is going to cancel the square, and I'm going to be left with R. And in here, there's nothing else to do other than writing the final solution. There you go. The square R is equal to the square root of G times M1, M2 over the force F. And so we have completed also this exercise. We have completed both. Okay, guys. So this is how it works. Okay, literal equations and isolating uh, the specified variable that you're given to isolate or to clear or to solve. Okay, so that's it, guys. And now let's go to the exercises.